Hi everyone, my name is Samantha and I did my presentation on anaerobic digesters, specifically focusing on the digesters at Mason-Dixon Farms. The definition of anaerobic digestion is when microorganisms break down manure and other organic substances to produce biogas. The biogas is usually a combination of carbon dioxide and methane. This diagram is an overview of the entire anaerobic digestion process, and I'm going to go through each side of the diagram separately. So I'm going to start with the left side of the diagram. The first step involves the manure and other organic substrates created by the cow being collected in the anaerobic digester. The digestate then goes to the solid separator where it is separated into solid and liquid portions. The liquid portion can either be stored in a lagoon and then used as fertilizer, or treated and then discharged into the environment, reused, or concentrated into fertilizer. The solid portion can be used as fertilizer, bedding, or it can be composted. On the right side of the diagram, the first step involves the manure and other organic substrates produced by the cow being collected in the anaerobic digester. The digestate is then converted into biogas. If water and hydrogen sulfide are removed from the biogas, then the medium BTU biogas is created and can be used on the farm to power boilers, heaters, chillers, etc. The biogas can also be used directly as electricity and used on farm or sold to an electric company. If carbon dioxide is removed from the biogas, then biomethane is created and can be used on farm or sold to an electric company to be used in the form of natural gas or vehicle fuels. The benefits of anaerobic digesters include reducing greenhouse gas emissions, reducing odor from storing manure, trapping and using the methane created, separating solid and liquid manure components, generating a product to sell, and reducing waste. One thing to consider before buying an anaerobic digester is the size of the operation. For example, anaerobic digesters are typically seen on dairies with more than 500 cows and hog operations with more than 2,000 pigs. Another thing to consider is the manure handling method on the farm. Anaerobic digesters work the best with liquid, slurry, or semi-solid manure. Anaerobic digesters are most efficient if at least 50% of the manure is collected daily. And the last thing to consider is the need for gas on the farm, or is there a market to sell the gas? The plug flow anaerobic digester is best suited for dairies that handle their manure by scraping. The complete mix digester is best suited for milk center wastewater or manure stored as slurry. The covered lagoon is used for manure handled by flushing and on farms in warmer climates. The upflow anaerobic sludge blanket is used for consistent and homogeneous waste, and the fixed film attached media digester is used for farms in temperate and warm climates. The anaerobic sequence batch reactors are used for manure stored as slurry, and high solids fermentation is used for high solids manure, and there's currently a bunch of research going on about solids digesters. Mason-Dixon Farms is a 2,200 cow dairy in Gettysburg, Pennsylvania that was one of the first farms to install an anaerobic digester. They currently have 3 digesters, and the first one was installed in 1979. Mason-Dixon Farms utilizes a horizontal plug flow system, and their digesters fuel 5 generators on the farm, which power the whole farm and some of the neighbors. Some of the benefits that Mason-Dixon Farms has seen since the installation of the anaerobic digesters are increased profits from selling electricity and digester solids, use of composted manure as bedding, and reduction of the need for commercial fertilizer because they can apply slurry to the fields. Scrapers push manure into liquid holding pits. The liquid holding pits are drained into the digesters, and hot water circulates through the digester to increase biomass production.